Good day, I'm Dr. T and welcome to my office. So today I would like to talk about stuff, specifically phases of matter. So if you've got a substance, it can be in a couple of different forms. Actually, it can be quite a few different forms, for which it is quite often useful to think about what we call a phase diagram over there. Okay, so on this phase diagram, typically we're going to see three regions. These are going to represent the three dominant forms that matter will take. The lines in the phase diagram and then the units on the side will vary depending on what the substance is. Typically the y-axis is pressure, how much you're squishing your atoms together, and then the x-axis is temperature, how fast they are bouncing around. The first phase of matter is the solid phase. In this case, you've got your atoms or molecules, which are clumps of atoms that are connected electrically. And these are going to be all locked together, and they're vibrating, but they're not really meandering around or bouncing around. So they're staying pretty much in place. Now, these can be in what we call a crystalline or an amorphous structure. Amorphous, they're just kind of in arrangement. They're no particular order. They're just kind of there. Think a pile of spaghetti. Alternatively, you could have a crystalline structure, in which case they are in a lattice, a regular repeating 3D pattern. Now, of course, you're thinking, hey, if I have a regular repeating 3D pattern, could I have two different regular repeating 3D patterns? Yes, you could. These are called isomorphs, and on some phase diagrams you will see a whole herd of them, and the solids will be broken up into different crystalline structures. Typically, that's more detail than you really need to jump into. Now, on this phase diagram, the next one you see, usually kind of lower down, is the gases. In this case, the molecules are vibrating so much, they're bouncing off the walls, they're bouncing off each other. They spread out. They've got tons of space because they are just moving. They're just trucking. Gases are predominantly empty space, actually. Typically speaking, for a gas, the size of the atom or molecule doesn't actually matter that much because they are clearing such a big space, bouncing around. They're basically doing social distancing, but with atoms. And, of course, in between is that of the liquid. So in the liquid, they're moving around, but they're not bouncing around with so much force that they are able to clear and keep a bunch of space. So they're staying close together, but they are not staying in place. So they're moving around each other. They're flowing, they're bouncing, but they are still close together. Now, that's usually about it for a phase diagram. Phase diagrams will quite often have another region, which isn't truly a phase. It's called a supercritical fluid. And in this area, things get weird. Material will behave both like a liquid and like a gas. And yeah, that gets rather interesting. Now, unlike other transitions, when you say go from a gas to a liquid, when you cross the line, that would be condensation, or going the other way would be boiling or vaporization. Typically, we don't call it boiling. With supercritical fluid, you're not actually crossing a line, so there is no phase transition per se. Yeah, those guys are interesting. I should point out there is one more phase that is quite often overlooked because it only happens under extreme circumstances, and that is a plasma. Plasmas are like gases, except for they're bouncing around so hard that the electrons get knocked off. These things have to be ridiculously hot, but they definitely do exist. So with that said, have a wonderful day.